Hi there, I'm Sean, and I'm a Senior AI Product Manager at JSI. This is part 3 of our AI Essentials for Investigative Intelligence video series, where we examine the core AI capabilities that matter for investigative work, specifically highlighting where they add value and share key considerations around their use. Now, this episode in particular is going to focus on computer vision. Now, before we dive into that, though, let's briefly review what we've covered so far and what's coming next. So far we've looked at specifically the data challenges that investigative teams face, and also how natural language processing tools can help make sense of language-based communications. Now, if you missed those earlier episodes, I do recommend that you start there. Now, in this part, however, we're going to shift focus to the next major AI subfield, which is computer vision. We're going to break down what it is and how it can help investigators process images and videos at scale. Now, after this, we'll move on to generative AI and then on to part 5, where we'll look at how these capabilities come together in emerging AI systems designed for real-world workflows. And finally, we'll wrap up the series with a discussion on compliance and ethics within investigative environments. So now let's dive into computer vision and see why it's becoming essential for public safety operations. Now, computer vision, again, is just another subfield of artificial intelligence. But in this case, instead of focusing on language, it's all about helping computers understand the visual world, images, videos, and really anything that we can perceive with our own eyesight. Now, really, the goal is to give a system the ability to interpret that visual information the same way that a person would, recognizing objects, spotting patterns, and drawing conclusions from what it sees. In other words, it's really the digital version of human vision. We're teaching computers not just to look at visual data, but to actually make sense of it and support decisions based on what's happening in that imagery. Now, computer vision again becomes incredibly powerful when you apply it to the visual data that investigators deal with every day. So as an example, we have mobile forensics, where computer vision again can rapidly scan entire photo libraries, spotting things like weapons, locations, and symbols as just a few examples. In messaging applications, again, it can help to triage shared images by automatically recognizing risky or relevant content. For surveillance video, again, this could be incredibly important with things like CCTV. Computer vision can help detect activity in objects or even highlight unusual patterns across long recordings. And it's the same thing with body packs or even drone-based footage. It can help pick out key visual details from otherwise chaotic environments. And especially in OSINT, computer vision can help, again, sift through large amounts of online images and videos, helping to identify visuals and information that's tied to people, objects, or even events of interest. Now, across all of these sources, again, the goal is the same. It's to turn massive amounts of visual data into fast, actionable insight for investigators. Now, again, we're going to look through a couple of different tools that are in the computer vision toolbox and things that you might encounter through different offerings that you're using within your investigative environment. And starting with that is kind of the most commonplace tool within computer vision is object detection. Now, again, traditionally, object detection is a series of models that are trained on a large variety of labeled samples. So you might have a massive data set that is trained on, again, cars and people and bicycles, traffic lights, what have you, that forms the foundation of how these models predict on new content where these important objects might be located, and then surfacing up that to end users. Of course, they can be fine-tuned specifically to the cases around law enforcement and intelligence. So looking more at things like firearms and being able to more predictably identify that particular object of interest within your collected content. Now, again, the important thing with these object detection models is, again, the quality and type of training data that these models are built on. So in this particular context, it's a very clear photo of a gun, and it's getting a very high accuracy or confidence score associated with that. However, in other cases, you might be looking at CCTV footage, which is lower resolution. The actual objects themselves are a lot smaller, maybe hidden in some ways. And so it's a lot more difficult in these types of environments to pick out those objects. And so again, you're going to have far more success using a computer vision or object detection model that's been trained on this type of source data. So if you're going to be running it on CCTV footage, chances are good that you're going to have much better outputs when you actually have a model that's been trained on CCTV footage with those objects of interest. So just something to keep in mind as you go forward with this type of technology. Of course, another kind of parallel capability in this space is facial recognition. And this is a big one within law enforcement and intelligence workflows, especially if you're looking for a person of interest within a broad amount of data that you've collected from many disparate sources. Now, typically how these things would work is, again, you are collecting all this data and you're labeling samples for the faces that you care about. So in this case, I have a couple images of Jonah Hill that I've curated and labeled within this particular tool. And as I collect new data into my operation, the model is going to start to be able to make predictions on the similarity of all those detected faces against those labels that I've already created within my environment. And so again, what we get is a similarity score or a confidence score of how well this new face matches the ones that we've previously labeled. And so you'll have to make some decision points at what point we actually want the system to make that automatic link, or what point the prediction is not confident enough that we can probably discard it because it's likely going to be incorrect. Now, interestingly, again, with facial recognition, it doesn't have to just be used for identifying faces. There are other avenues that you could use this technology for different purposes. A great example here is just determining not who this person is, but also looking at their face and whether or not they're wearing the mask properly on their face. And so again, there's other ways that this type of technology can be used when you're doing this facial analytics type of work to better harness it for your specific use cases. So again, this may not be an applicable example, but what I want to get across is that you can train these models to look for different things based on different attributes that might be of interest to your workflow. Now, another very important tool in the computer vision toolbox, again, is optical character recognition, or OCR. Of course, with a lot of the content you might be pulling in, again, maybe it's from mobile forensics or device forensics, maybe it's from social media, it might have images with a lot of text content as a part of it that might be critical to actually understanding the relevance of that particular piece of data. And so what OCR does is, again, it looks to extract that text from the source image and then expose it downstream so that we can start to run additional analytics on top of it. So in this case, again, we have an image of a national identity card, but it's a picture. And so the first step we have to do is run OCR, extract the text, and then that means we can now expose that text downstream to some of those other natural language processing tools that we talked about earlier on in the last video series. Now, of importance here to call out is that, not all OCR tools are made equal. And again, it's going to be very dependent on the quality of the training data that these models were built on top of. And so in this case, what you'll see is that we start to see some instances where these models can struggle. Sometimes it's rotated text like we see here, different fonts, different contrast of the font against the background, the resolution of the image. All of these things are going to play an important factor in the quality of the OCR output that we actually obtain. And not only that, but again, these models are only trained on specific sets of data. And so if your training set is not diverse enough to include different languages, then it's going to struggle with pulling out, say, different character sets like we see with Arabic. And so if you want to be able to pull out Arabic text or different kinds of character sets or alphabets, then you'll need to make sure that the model that you're using for OCR actually has been trained on that type of data and can perform in those environments to the quality that you would expect. So something else to keep in mind as you're selecting and testing out these different tools within your environment and against the data that you specifically care about. Now, another important one is image captioning. So again, as a human user looking at a particular image, this isn't tremendously valuable. I can use my own brain, use my own eyes to determine what's actually in that image. However, again, if we're looking across massive amounts of data, we might want to be able to easily search for particular types of content, or we might want to have additional processes, again, like text classification, run on top of these images so we can more easily identify things that might be relevant to our particular operation. And so what image captioning does is it can create either very brief or very verbose captions about what the model happens to see within the scope of the image. So in this case, we see a small airplane on grass. We might see a group of people on scooters in a busy city street. In this case, it might be a syringe in a pile of powder or a bag of marijuana with a red background. Now, again, we can make these tools go as verbose as they need to be. So if you want it to be extremely descriptive about every single little detail, that is possible. There are models that will help do that. And again, make sure that that data is then exposed downstream to help extract more actionable intelligence out of that content so you can find relevant things across vast data sources much faster than through traditional manual triage. Now, again, like we did with the natural language processing video series, we're going to try to put this all together into an example workflow of how all of this can be chained together to help drive decision-making and actionable insights. So again, on the left, what you'll see are the different types of visual data that investigators often deal with. Could be images from mobile forensics devices, could be, again, surveillance footage, or even screenshots from messaging apps. Now, this is really, again, where computer vision helps to augment this information and make it much more usable. So again, in this case, what we're going to do is have the initial enrichments that are going to create things like image captions. So we have a person leaning against a white vehicle on the street. We might want to pull out the different types of objects that are identified, the car or vehicle, and the person as well. If we have a facial recognition system running, we might want to match this face against other faces that we've seen so that either it's an unidentified person, but we know exists in our data set, or we know that it's John Smith, who we've seen before and labeled his sample data. And finally, again, we can run things like OCR so that we can extract that text to expose it downstream. Again, maybe that particular license plate is of importance to our investigation, and now we can search for it very quickly, despite the fact that we have millions and millions of images in our particular data set. So again, all of that then feeds downstream to help trigger things like alerts, linking to other data sources, or even supporting other generative AI assistants, really helping to accelerate the path from visual evidence all the way through to decision-ready intelligence. So that wraps up part 3 on computer vision, and I really hope that you found that one useful. Now, in part 4, what we'll do is dive into the very hyped branch of generative AI and really dig into that a little bit more detail to see what that really is and how that might actually play into your investigative workflows. Part 5 is where we'll bring all of the subfields of AI that we've talked about and show them in emerging AI systems that apply specifically to law enforcement and intelligence operations. And then, of course, part 6 will wrap up with a very important overview of compliance and ethics, especially within high-risk investigative environments. So thank you again for watching. I really hope to see you in the next part. And of course, if you want to learn more about JSI, please do visit us at jsitelecom.com. Thank you.